Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following two-dimensional trigonometry of angle question. Please don't forget to click on the like and the subscribe button below for more easy to understand math concept. Refer to the figure shown below. PQRS forms a straight road with TQ, another road that is perpendicular to the road PQRS. The distance RS is equal to d kilometers. Angle T1 is equal to angle T3, which is equal to alpha, and angle QTS is equal to beta. The first part of question says, write down the size of angle QTR in terms of alpha and beta. Starting with the first part, if we look at the diagram, angle QTR, I'm going to highlight that, is the angle shown, such that we have angle QTR is equal to the total angle QTS. So we have angle QTS minus we have angle RTS giving us alpha. So we have angle RTS. Therefore, angle QTR is equal to angle QTS. QTS is beta minus RTS. RTS is alpha. So we've been told to write that angle in terms of alpha and beta. So that's beta minus alpha. Going to the second part of the question, we have in triangle SQT, write down the size of angle S. I'm going to start by drawing out the diagram. I'm taking out from the original diagram. So we have this as S, we have this as Q, and we have this as T. Note that angle or this line PQR is a straight line such that the other angle at Q will be a right angle. So I'm going to put a right angle as shown. Then we have angle QTS. From the diagram, we have the total angle to be beta, such that the sum of all the angles will add up to 180. That's the property of a triangle. All the angles add up to 180. So we have angle at S plus the angle at Q plus the angle at T equals 180 degrees. And the reason being, the sum of angle in a triangle add up to 180 degrees. Therefore, we have angle at S plus angle Q, that's 90 degrees, plus angle at T, that's beta, equals 180 degrees. Therefore, to find angle S, we're going to make S the subject of formula. Moving all the other angles to the right hand side, it becomes 180 degrees minus 90 degrees minus beta. So therefore, the angle at S is equal to 180 minus 90. That's 90 degrees minus beta. The third part of the question says, in triangle PQT, write down the size of angle P. The angle or the triangle PQT, I'm going to highlight that in the diagram. Triangle PQT, using the same rule that states that the sum of angles in a triangle add up to 180 degrees. So we have angle P plus angle Q, that's 90, plus angle T, so that will be angle T1 is equal to 180 degrees. And the reason being that's a triangle PQT. Therefore, making P the subject of formula, I'm going to fill in the values that I have first. I have angle P plus angle Q, that's 90 degrees, plus angle T1, that's alpha, equals 180 degrees. So therefore, angle P is equal to 180 degrees. I'm going to move the other two angles to the right hand side. So that becomes minus 90 minus alpha. Therefore, angle at P is equal to 90 degrees minus alpha. The fourth part of the question says, determine the length of RT in terms of alpha and beta. So, because I'm looking for the length of RT, I'm going to use the diagram or the triangle RST. So I lighten that. I have RST as shown. I'm going to draw that out quickly. So that's the diagram as shown. To find the length RT, I'm going to use the sine rule. So using the sine rule, the sine rule states that the ratio of the side RT over the sine of the angle facing RT, that's sine of angle at S, is equal to the ratio of the side RS over sine of angle facing RS, that's sine of angle T3. Slotting in my parameters, I have RT, which is the missing side, over sine of angle at S, that's 90 degrees, minus beta, equals the line RS, that's D kilometers, D over sine of angle at T3, that's alpha. So simplifying what I have the side RT over, using the cofunction sine 90 degrees minus beta, the trig identity, that will give us cos of beta, equals, I still have my D over sine alpha. Therefore, using cross multiplication, I am going to multiply both sides by cos beta, such that I have RT, or the length RT, equals D times cos beta divided by sine alpha. So RT equals D cos beta over sine alpha. Let's look at the next part of the question that says, ends or otherwise show that the line PR equals D cos beta sine beta divided by sine alpha cos alpha. Because I'm looking for the line PR, I'm going to use the triangle PRT as shown, and drawing out a rough sketch, I have PRT as shown. I have P, R, and T. Putting in the values that I have angle at P equals. From the third part of the question, we've been able to show that the angle at P is 90 minus alpha. We've also been able to show that the line RT is equal to D cos beta over sine alpha. Therefore, to find the angle at T, going back to the question, the main diagram, angle at T, that's to find T1. T1 is alpha, T2 is beta minus alpha, so therefore T12 is equal to alpha plus beta minus alpha, which is equal to beta. So I'm going to put that as beta. So therefore, using our sine rule, note that we are looking for the line PR. So using the sine rule, we have the line PR over sine of the line, or the angle facing the line PR, that's sine of angle beta, equals to the ratio of, I'm going to call that sine T, and then I substitute in the next line. So that's PR, the ratio of PR over sine T equals the line RT over sine of the angle facing the line RT, the sine of 90 degree minus alpha. So simplifying further, I have PR, or the ratio of PR, over sine of T. Now that's sine of angle beta equals RT. RT has been given as D cos beta over sine alpha, as explained or as shown in the last part of the question, that's question 4, over or divided by, I'm going to make the one longer, sine of the angle facing the line RT, that's sine of 90 degree minus alpha. If I'm to simplify further, I have PR over sine of beta equals, simplifying my right hand side, I have d cos beta over sine alpha divided by sine 90 minus alpha. Using my identity, that becomes d cos beta divided by sine alpha, that's all divided by, that's a cofunction of sine, that's cos alpha, and that's also equal to d cos beta divided by sine alpha times 1 over cos alpha. So that will be PR over sine beta equals d cos beta times 1, that remains d cos beta, over sine alpha cos alpha. And therefore, multiplying both sides by sine beta, I have PR equals d cos beta multiplied by sine beta divided by sine alpha cos alpha. Note that we've been able to show that PR is equal to d cos beta sine beta over sine alpha cos alpha, as stated in the last part of the question. Thanks for watching. Bye.